Hello everyone, in the last video we were able to teleport around on the map, but the issue with that is that the server accepts every position the player set himself to, and this is what we fixed today. We do advanced movement on server side. So first of all, we save the player position, so when we relog in we start where we were. Second of all, we fix teleportation on server side, because the third option will destroy teleportation only client side, because the server will check if the client is actually moving too fast. The first thing I implemented when I wanted to implement those three features was let the server not allow the player to move to a position where he shouldn't be from distance perspective, so the player can't have a speed hack or something. For example, when we have the game running, we have the server also running, and when I change my position to, let's say, a ridiculous amount to the left, the server forces me back, and the same goes for up and down and everything. We can't cheat, but we can move in the speed the player is allowed to. And this is actually quite easy to implement. First of all, we need a way for the server to detect when movement is illegal in our case, because it's too fast. And the simplest way to do that is in the server, where we get the messages from our client with the new position. We do some checks. First of all, we need to know the last known position, which in our case will be saved into the last accepted player state message. Like the name says, only accepted player state messages are in here. So when the player gives us an illegal movement, we don't save it in this variable. So there are two states this variable can have. It can be null, then we don't know anything about the player. This is an edge case where normally the player needs to spawn in the world for the first time. But for now we ignore that case and accept everything the client sends us for now, because we have no deaths and spawning at the moment. But after a state is known, then we can check against that state. And every state for us has a server time, which mimics the time of the server as best as the client can, because we have some time synchronization and we use basically some sort of NTP algorithm to find out what the server time is. And there can be a time difference, which is round trip time half. So half the round trip time, let's say you have a ping of 200 milliseconds, NTP can have a variance of 100 milliseconds. But this is not a big deal, because the difference from what the player thinks is the server time and what the server time actually is will be consistent in itself. So when the prediction of the client is 50 milliseconds off, it is always 50 milliseconds off, so the server can work with that. So we know our time when the last message was saved, and we know the time from the new message that the player sends us. In the last time already, we don't accepted messages which are in the future for the server, because this never can be the case. When a position message or a state message in our case comes in, because of network latency, this always has to be in the past. It is not possible that the server time of the client could be in the future. Then we don't accept messages which are very old. For example, 2 seconds old for a player update state. We currently send them with 60 or 30 FPS. So there should be a message which is not that old. The next thing is we check if we know a state. This should never be false when the game is finished, because when this is null, then we need to trigger our spawn algorithm where the player first spawns in the map. when this is because we don't know where the player ever was because he never spawned. Later we will save the state of the player. So when the player relogs in, he gets at the same spot where he logged out, basically. Then if we know a newer time, then we don't need to deal with the old message because we accepted already a new state. We don't bother the old one. We could change that if we want to have some clearer path what the client has done for BI and everything. We can do that, but for our game logic it's not interesting. And it can happen that a message delivers twice to us, then we ignore that already. So the first thing we need to calculate is what is the difference in time between the last accepted player state and the new player state we get. This is easy done. We remove from the current server time the server time of the last known state, and then we do some time calculation because we work with ticks here, and we calculate divided by ticks per second. So 1 second will be 1, 500 milliseconds will be 0.5. So we have the diff in state time, and since we do some calculations, if this is 0, which shouldn't be the case because the only case this is 0 is here, but for safety, if this is 0, we ignore that because we will have a divided by 0 issue if this is 0. But like I said, this shouldn't be the case, but we save it still. And then the next thing we want to know is how far did the player move. And this is also, it's the same with the time, just with the position. We subtract the position from each other and then we calculate the length squared. We could use the length instead of the length squared, but the length actually calculation is, if you know Pythagoras, since we are 2D, it's just 1 time Pythagoras. If it's 3D, then it's 2 times. But it's really easy to understand. Pythagoras is a squared is equal to b squared plus c squared. Or I think Pythagoras does it like that. It doesn't matter, it's the same. And if you want to solve that for c, then this is the square root of a b squared. And square root is very bad algorithm for CPUs because it's kind of rough. It's CPU intense. And since we compare distances with each other, if both distances are squared, then it's fine. And so we can get rid of this square root by just working with the squared values. Then it's just a squared plus b squared, which is in our position x multiplied with x plus y multiplied with y. And then we have the length squared. That's in 2D very easy to calculate. And then we have the distance the player moves. So to balance the distance the player moves per second, we divide the distance the player moved by the time. So let's work that out together. So let's say that the players moved 1 meter in 500 milliseconds. So this basically means that the player can move 2 meters in 1 second, right? Let's say the players moved 1 meter in 2 seconds. That means that the player can move 500 milliseconds in 1 second. So let's fill this in here. Let's say this is 1 meter. Then 2 seconds means in our calculations, server time minus the last known server time, which should be 2 seconds of ticks. We calculate this in ticks. So this will be a 2. So the 1 meter divided by the time 2 means 500 milliseconds. So this is correct. This also works in the other way around, where we had 500 milliseconds here. Because this will be again 1 meter just for easy usage, and 500 milliseconds is 0.5, and 0.5 is basically divided by 0.5 is basically the same like multiplying with 2, and 1 multiplied by 2 is 2 meters per second. So that's how we calculate how much speed has the player currently per second, and then we compare that if this is too fast. And how do we do that? We calculate the max player speed that we allowed. Currently the player can move in the x direction 20 meters per second and in the y 35 meters per second. And then we do length squared again, because like I said, to get rid of the square root, we compare squared lengths with each other. Then we have some little epsilon, so we allow a little, we are a little more lean with the speed, so when there could be lag and something, and values could be getting really close to each other, and this epsilon will get rid of those mathematical errors. So if the player moves 0.1% faster than he should be, that's fine. And if that's not the case, then we actually say that our last known state is the current state of the player, because we will send to the client a message with force position true, which basically the player can always only get force position true for himself. When he gets state from other players, force position is always false. So when the player knows, when on Unity side, when he gets a message with force position true, he knows that he messed up. But first of all, I want to show you how I get the numbers 20 and 35 here in max player speed. Sorry for jumping around. So the 20 and the 35 is basically a configuration on my player character, because my player controller directly modifies the velocity of the rigid body, and it says speed 20 and jump velocity 35, and I directly modify the velocity of the rigid body. Rigid body velocity calculation is this meters multiplied by the time that has gone, and so the distance is my speed multiplied by the time. So that's how the max speed comes per second, because we basically use the same values on client and server side, and the mathematics will go the way with it. So when the client gets a message with force position true, then the client will get basically teleported to the position where he was. So I leverage the same system which we used for client-side teleportation, and just on awake I register for player states, and I ignore every player state here which isn't force position true, because I'm just interested when the server wants me to force a state. So the server sends me to force a state. I can't set the position here directly, because this will tinker a lot with Unity objects like the rigid body, and I don't want to modify rigid body stuff in another thread. And this could be another thread. It is synchronized now, but we can synchronize that with our movement at the bottom. So we set the force position and the look direction, and the player's force to the position. This is everything we needed to make cheating impossible, but this also destroyed our teleporting system, because teleportation basically was Unity setting the position of the player to the bottom, which isn't working anymore. And you might think for yourself, this is an easy fix. The server just needs to do the teleportation. And this is what I thought to myself, and this is also how we implemented that. But there's this little tiny issue. How does the server know the position? And I don't want to hard code the position of NPCs on server side. So first of all, we need to give the server the knowledge about the NPCs, in our case, the teleportation stuff of our map. So what I've done in Unity is our map fluff stuff. So we can have multiple maps here and we can deactivate, activate them, or even load them from different scenes. I haven't made my mind up how I want to implement that. That's a future me problem. But for now, I have a map script which has a name and it has a little button, Save Map. And if we look in the map script, it actually does nothing. It just has an object for the name. And we have an editor script for the Save Map. How does this work? We need a folder with the name editor. And if you have script in a folder with the name editor, then this is behaved as an editor script. That's how it functions in Unity. And we have a script like that located. We have a folder like that in the root, which is editor. And there we have map editor. And map editor is an old style editor script because this is way easier to do the old style than the new one. In this case, so we have a custom editor for the type map. Then we inherit from editor and basically we call base on GUI. This does everything the normal editor for Unity does. So in our case, we see our name tag and the script thing, which is for every mono behavior. And I can add more variables to the map and they will go in here because it will be rendered by the base inspector. But I will add a new button. If I do if GUI layout.button and give it a name, this button will appear. And Unity is honestly really strange for a UI system to work that way, but it is in Unity that way. If this call is true, then this button is clicked. Whoever came up with that idea is really strange because I've never faced a UI system that worked this way, but in Unity it is this way. So when the button is pressed, then I open a save panel and I save the map. So basically I press it, I open a save panel and I can save the town map. And what it does, it gets every NPC controller, generates map data, which just holds the name of the map and a list of NPCs. Then we save all NPCs there and then we JSON serialize write the file. I convert the NPC controllers to my NPC data, which basically just holds the name, is it a teleporter and the position. That's everything the server needs for now. We can later add stuff. And the NPC controller gets a new variable is teleporter, and our NPC Hans is not a teleporter. So we have here is teleporter not, and the other twos are teleporters. On server side, easily we add the file to the map service. When you add a file like that, you go to add existing object, and let's say we want to add our Unity client assets, streaming assets, all files, and we want to add the maps town map. If you press add, then the file is actually copied over to your project, and this is not what I want. So if you press this little arrow here, you can do add as link, and this is what I have done. The difference is this is now a link to the actual town file in the folder of Unity. So when this file changes on Unity side, this file also changes on server side. If I press add and the file is copied over, I need to remind myself to copy over the file when there are changes done in Unity, and I really don't want that. So I link the file and I don't add it. And this way we can also check in the project file how this works. There is an include and there is the file referenced in our assets folder in Unity, and it's linked to where I want to have it linked. So this makes it really easy because we have this file just one time and not 2 times. So now the server knows where to teleport a player to if the player wants to teleport, and there will be a new message obviously because we have a new command. And commands always in our project go into our protocol, which is in the common. So we have a protocol for our map system, and we have a teleport message. And everything the teleport message has is a name and serialization and deserialization of the name. We have a new message type teleport, and the client for our map gets a new function which is in the workflow. Where is it? Send teleport to. And this basically just sends the message to the server. Our map listens for this message. So when a teleport to message comes in, then we check, does the NPC exist that we want to teleport to? If it's not exist, we return, or if the NPC is not a teleporter, we also don't allow that. So people can't teleport to Hans to have a fast way to fulfill his quest, so they have to use the teleporter, which currently is next to him, so no big deal, but there will be later in level designs where teleporter is not actually directly next to the NPC. So we definitely don't want that. Also, we need to know a state of the player. This is just because my lazy programming, but the state actually comes in the first time the player logs in. So this basically like initialization, but I was lazy to do it. And what we do, we set the last known player state to the current time, and we set the position to the NPC position. And then we send a false message to the client. For the server, with these 2 lines, the player has the position. And then we just inform the client that he has to move to that position, which he will conform and do. Since there's a delay between those 2, there's a delay where the server says this is your new position, and the client will say, okay, this is my new position. This will actually trigger our speed hack, which is no big deal because also what the speed hack does is also set the player to the position where he should be anyway. So this is no big deal. But if you're wondering while debugging why this is triggered, it is triggered because the server teleports you over, but the client still sends the old position. And this is not fine, and the server will force the player to the new position. No big deal for the algorithm to work or for the programming to work like we want to, but it is a little strange for debugging. So when teleport up is triggered, we send a message to the server. Server will send a false message up. So we have hit 2 birds with 1 stone because of the false position implementation we needed for the anti-speed hack. So in Unity, teleportation works with the behavior graph. I showed that last video, so I don't want to show that in depth now, but we have a function teleport to implemented. And if we look into the new implementation of that, we see that this is a script engine feature with the teleport scope, and there is a function teleport.to, and this is changed. Last time we set the player position, we forced it on client side, but this time we just publish a teleport message. The map client wrapper will pick up this message. If I go on the type and not on the constructor, we see it subscribes to this message and it will just call the workflow. So we publish the message and it will be sent to our server that we want to teleport, and he does the same with the fourth position and comes back. So this is the whole teleportation implementation and our basically anti-speed hack. Now when I go here now and I wait for a couple of seconds, I will cut the video. I've implemented it in 10 seconds, or no need to cut the video, maybe I can explain it. We save the player position to the database now. So we have this map collection here. Let me show you. And there it saves the player position and is he looking right or left and everything. One entry for each player. There's an issue with that because I don't want to write to the database 60 times per second for each player, which would be mayhem and very expensive to do. What I did is, we have a last time we saved the state of the player and we just save it every 10 seconds for now. We could increase that to every second, but what we actually do is every time a message comes in, we check, did we save any message 10 seconds ago? If that's not the case, we will save it. And when the player disconnects, we also save the last known state. So we have disconnect and maximum loss of 10 seconds when our server crashes, which should never be the case, but we will be safe that the player just loses 10 seconds of movement if our server crashes in any state. And this is everything I have for you this week. I wish you all a great week. Have a good day. Bye. And like always, I want to thank my Patreon Julian for supporting this channel.